Hey guys, what is up? So apparently, 1,000 people think this channel is worth watching. Honestly, I never thought that would ever happen. So to say a little thanks to everyone for subscribing, we're gonna do some fun stuff with microcontrollers. So with all the new cars and stuff coming out on the market, we have a whole bunch of things happening. A lot of cars are using more and more code. You got CAN bus communications. It's not as straightforward as it were. So I would like to give you guys some info on microcontrollers, a short introduction how they work. So this is going to be a part one of two video. The second one is where we actually put this contraption on the car to give you an idea of this what it looks like. We have a fuel pump controller here set up with a little bit of a battery and everything and a controller. We've got some hectic code running over there. So yeah, so this is going to be the first of many new things to come. So the channel is going to change a little bit more into things that I wouldn't say future-proof things, but it's more going to be the more advanced stuff that works with microcontrollers, computers, tuning, a whole bunch of other stuff coming through. To like just help the industry for the enthusiasts. Like I started this channel back in the day, which was for technicians who are really struggling, and there's no information out there. And I feel personally, I believe that information should be free to everyone. You shouldn't hold all that for yourself. Like I love the saying where someone said, it's amazing what can be achieved when no one cares who gets the credits. And that's kind of what I based my channel on. And for some reason, people started watching it. I never thought I'd ever get 1,000 subs. But yeah, so anyway, less of that talking. Let's get into the video. So you get these cool little things called microcontrollers. And I get the Arduino Uno, which is this one, which is basically, I believe, an Italian company that took all these robotic components that are like really difficult to work with and put it all in one easy to use solution. And then they made it open source, so anyone can use this. So this is just absolutely great. I love the idea of that. So that's why I thought, you know what, I'll base some of this. Now you get one of these controllers like this one. This is the Uno. Let me get the light on there so you can really get an idea of what it looks like, right? So this is actually actively running. It's hooked up to a computer there, the USB port, and we've got the code running here. So this is essentially a robotic controller. This is common in people that build robots and things like that. And then that has a little bit of a sensor here. And then this model here is known as an IB or BTS7960, which is a small voltage that runs a big voltage. But I'm going to show you guys how to do that. Now this is just the bench test. The actual test is not going to look anything like this. And then also I did a small one here. This is the Arduino Nano, little tiny little controller like that. And I just use an old TPS from a Ford and just use that as one of these switches just to make sure that everything works. Yeah, so basically, let's have a look at the board here on the front end. Let me zoom in there and get some focus. So you have all these pins on the left. Let's get a better focus on it. Sorry, it's not the most advanced setup here working from the house today, not the workshop. So you'll see on the left side, you've got a whole bunch of A's, A0, A1, A2, A3, A4, A5. And that is basically your analog inputs. Now that's just the fancy way of saying you're going to get a signal input here that's going to vary between 0 and 5 volts. So these guys can only run up to 5 volts, and the current they can draw is very minimal. So you don't want to put a big battery on this and just throw all the power in there. It's not going to work that well. And let's use this pencil, because this fancy little chipper is actually removable. Now that's the microcontroller, which allows us to do all these things. And obviously you got your V in here, ground, 5 volts, 3 volts, and then some reset stuff in there. And over here we've got the output pins. So these ones have little squiggly lines there, which means that's basically PWM, or pulse width modulation. So basically, if you flip a switch and you've got 0 volts, and if you flip the switch on, it's 5 volts. And if it's off, is 0 volts again. So that's the digital, like it is there or there. Pulse width allows you to do that so quickly that the voltage actually slowly tapers up or tapers down. So we're going to have pins here running on pulse width modulation, and then just the high and the lows, and also the ground pins and all that, and these things. So there's a lot of information on these. You can do so much with these. So for this application, let me just zoom out here. We're actually going to be looking at building a fuel pump regulator. So let's say for some reason your fuel pump works, but it just doesn't give the fuel through. So we can use one of these to basically rebuild it. So the total cost of this is less than fancy controllers and ECUs and all those other lovely things. And then obviously here we got this component here. This is the BTS7960. It can carry 60 amps of current from I think 3 to 12 volts or something. And then it uses these things here. Probably shouldn't touch that with graphite. But they can basically, they form what's called the H bridge, which means they can take the current the one way or the other way and just do that really fast to allow you to control it. So what we're going to do is we're going to hook up a fuel pressure sensor on this, and this here is simulating that sensor. So we're going to get a signal from 0 to 5 volts, which we're then going to read with a little board here, and that's going to affect our motor speed here, right? So we got our little 12 volt here, just a little test bench, and then this is an old fuel pump motor I just took out, running up there. Okay, so to hook this thing up, if you want to look at that, you have your sensor coming in here. The sensor one is your signal, and then I think which one is the green? Ground is blue. So on this one I'm using blue as ground and green as 5 volts, so pulling it all the way here. So it has these VN here. Now VN is basically the whole 5 volt circuit inside this, and then blue is obviously we're going to use the ground for that, and then that there A1 there, that is going to be our input signal. And then this one here is, I'll explain that 5 volt. So this basically, this 5 volt here and that ground there, that's going to power this guy here. So if you look at this thing here, this controller, and you'll see there's a little bit of numbers and things there. Let's get a nice focus on there, right? So you got VCC, you've got ground, RL, and a whole bunch of weird little numbers. So it's going to go through this. So VCC is basically your voltage input. So 5 volts go in there, and then ground is your ground. Like if you know about electricals, that's how it works. The RIS and LIS is kind of like a alarm or sound signal or something that comes through. So basically it has to do with the current on this, and we don't really need to know if the fuel pump is on or not. If the car doesn't run or we can't hear it, we're going to know the fuel pump isn't working. And then you get this REN and LEN. So that's basically like the engage button. So we're going to, for this thing, we're going to pretend that R stands for right and L is for left direction. So basically clockwise and anti-clockwise rotation of the motor. But you can do so many things with it that it really varies. And then here at the end we have the fun ones. These are the PWM. So that's basically going to send it pulsing in that direction, and that's going to send it pulsing in the other direction. And here we've got the cables. So red is for REN, orange is for LEN, and brown is going to be or PWM, and yellow is going to be LPWM. Sorry for the shaky hands, I'm really zooming in really close on this, so I guess it's really hard to see this. Okay, and then here on the other side, we're going to be connecting up our voltages. So on the bottom it has little signals there, or numbers marked on there, so but I'm not gonna flip this around. That's just motor negative, motor positive, battery negative. And if you look over here on the plus side, flipping things here very acrobatically, there's a plus on the board right there. The camera doesn't show it, but there's a little plus symbol there so that you can't get confused and accidentally put the negative in, because if you do that the wrong way, you're going to blow the board. Okay, let's zoom that back out. Now all this is really cool and everything, but the thing is you're going to need some code to run this. So the code is going to be in C++. I'm just going to drop the flash off there. We can look here at my computer screen. So on this side, we're going to be looking at integers. So integer is going to be that guy over there, and we're going to say RPWM is equal to 10. So that's going to be pin 10 and integer, and that's going to be, so we can call that flashy line, we can call it Dave, we can call it Supra, whatever we want, we can call that there. But we're going to stick to the coding so that we know if we want to check if the color is correct, we're going to check with the name RPWM. We're going to look at the little controller here, look where that is, trace the color back there and check if that color and that one matches up. Okay, so then LEN and REN, we said what they were, and then obviously these are the ones on. So they are not pulse width modulation pins. I just suppose you can probably use them, but I found these to be a little bit better than that. Okay, and then that's going to be, and then for the input, we're going to have a little analog input here. So this is going to be an analog signal that's going to go in here. So it's going to give 0 to 5 volts around about there, right? So Okay, let's maybe zoom in a bit here so you guys can see the code a bit better. Hello, focus please, thank you. That's much better. Okay, so we got our integers here of the len and rem, len, got the pwm, and now here, fpv. So we are managing a fuel pump. So what's going to be, what do you think that's going to be? That's going to be fuel pump voltage. That's going to be the voltage we're going to send through as our input signal, because we're going to get a voltage in of some arbitrary range, and we're going to calibrate that in to be in our board. And this FPS is going to be fuel pump speed. So like I say, you can call a fuel pump, you can call this input voltage there. You can pretty much name these anything you like, as long as you have the integers there and the pins. So with the analogs, we're going to have, say, A1. So there we got a little comment there with little dash dash. So the code here doesn't run. If you see two little dashes with something next to it, that code doesn't run. And then obviously once you have the input voltage, we need to put that to some speed. So we're going to put the integer there, AP0. We're going to come back to this later just to see how these two are related. You know, why you need two inputs instead of just putting one in. Okay, so the setup here is going to be the second part of the coding. There's a lot of videos out there on how to do this, so I'm not going to put too much effort into this, but we will get there at a later stage. Just for now, on argument's sake and demonstration purposes, we're going to give this through here. So this is basically how you put the on mode. So this is basically what happens when you put the key in the on position, if you want to look at it that way. Because we're going to be working on cars, so we're going to use car analogies to describe these things. So when you switch the car on, your pin mode I and output is going to be happening. So you're going to be working with that. Digital write is the word that you use to sort of send the signal out, if that makes any sense. So pin mode is going to be an output, and then I is going to be the value that we're going to be working with. And then if I is less, so I think I can probably tidy this code up a little better. But for now, we're just going to work with this, because I think I was a little busy experimenting with other things and I kind of forgot this little part in there. But this is the code that I'm running. Okay, and then the void loop. So the loop is basically a type of coding, what should I call it? Coding function, where something is looping. So it runs a cycle and then continues running it over and over until you basically get to the element you want. So you could use loop, you could use while, you could use probably a switch statement could probably work here as well. So if you want to do like staged like stage pressures and things. Okay, so digital write and digital write. That means for the REN, which we have named up here, REN, there he is at pin 12 and 13. Is going to be high. So the digital outputs are like ones and zeros. They're not like the analogs. The analogs can be adjusted, but digital is like high or low, high or low. It's one or the other. So we're going to start these off at high, both of them, because we're not still sure we're going to go clockwise, anti-clockwise, we're going to go left, we're going to go right. So it's I think I did try the ones putting one low and one high, and it didn't work so well. But eventually, I just put it high. And like I say, this is still a demonstrative purpose, so we are going to put this in the carousel, and the second video is going to follow up and you'll see exactly how all of this actually works. And then a delay is kind of like how much time is it going to be before this thing runs through. So it's going to start up with that and it's going to run through. So now we're getting to for parts. So this is the coding. So to start a for loop, get the loop to run in circles and circles and circles, because we want to basically run a loop, check the pressure, run a loop, check the pressure, run a loop, check the pressure. And every time the loop runs, it's going to adjust that voltage, causing the pump to run higher or lower or faster or slower to account for what we're trying to do here. Okay, so that's high now, so that basically starts off high and it stays away. So if we were to put this in the loop, it would probably send on and off, on and off. Every time there's a delay, it's going to shoot on and off. So as it starts, this thing is already on. They're on all the time, right? And then obviously the delay with the cycle. Okay, so we can start with the integers. So with computers and stuff, they start at 0. 0 is actually the value of 1. And then the outputs can run from 0 to 255. So 255 is like 100% power. 0 is 0% power, right? So, and then we're going to say that we can use X, we can use A, B, D, E, F, whatever you like. You can even call it Dave or whatever, but as long as that value there, I, is the same throughout, it'll work. So what exactly are we doing here? So we're saying that I here, it could be X, it could be Y, it could be anything. It's going to start at 0. So I starts at 0. There we go. If you look at our serial here, I is 0. This is actually currently running, so we're getting new things. So if I say basically clear output here, their eyes are going to come through. We're going to see the eyes running through there as it goes, right? So then we're going to say that I can't go higher than 255 because that's max power. So I has to be less than 255. Right, and obviously we can separate with the colons and that. There's a lot of stuff about people doing these kind of things, so I'm not going to give too much about the code just yet. We're just going to use this for example just to show how it basically goes. And we're going to say that I is equal to FPS, so fuel pump speed, which we have defined here, FPS. So now FPS, whatever we write there and there is going to be 0, right? So we know I is that. So now we're saying, but the fuel pump can't be 0 all the time, otherwise we never get any fuel. So here we put on a little interesting thing. We say if FPS, so fuel pump speed, is less than 30, which means that the value that I is, which is FPS, which we have set to be this thing here, FPS is 0, because that's going to be the speed running at. If it's less than 30, we're not going to run anything. We're going to say I is equal to 0 that, because the motor is going to be running so slow that is really not going to help. So we're probably going to adjust this value later on, because running at 15, it's about 10% of the pump's ability, is not really going to do much on that. I do think that I needed to just say where FPS becomes oh, there we go, there's the analog read. Okay, so we're going to say if the value is less than 30, it's just a numerical value. So like think of it as RAM. As if you have 256 megabytes of RAM, where 256 is the max and 0 is there, we're going to run just 30 of that. And then if it's less than or equal to 30, I is going to be 0 and the motor is not going to run, right? Okay, so here on the next one, we're going to be that the fuel pump speed, because now we've said the fuel pump speed is anything less than that, we're going to do that. But what is the fuel pump speed? Like, what does that mean? This is just a bunch of letters, right? So we're going to say fuel pump speed is going to equal the analog read. So when we say analog read, we're going to tell the Arduino and say, hey, we've got this voltage coming in from FPV. You might want to look at that because let's do something with this voltage. So FPV, we have now said here, is equal to A1, right? So there's an FPV A1. But it needs to first read what FPV is. Now the thing is, with the analogs, it's going to come in, I think, with 1 bit of information, which means it's 123 right there. But we're not working with 120, we're working with 255 because we can only go there. If we put this thing at 255, oh man, that's not going to add up. It's about 400% what it's supposed to. So we need to use this little map function and say FPS is equal to that, right? So now the program has determined that, okay, so whatever this is going to be this thing, whatever the voltage is, in a bit value. And then we're going to say that is equal to FPS. But FPS has to now be between 0 and 255. So we're going to use this thing where we say map. So we're going to take map, we're going to take the function of FPS, and going to say between 0 and 123. We're going to change that around. So we're going to run this map function, and that's going to change it to 0 to 255. So the output is going to be somewhere between 0 and 255. So this 255 is going to be 123, but technically divided by 4. You can probably say that divided by 4 as well. Give you a similar answer, but I found that this just works better. And then once we've done all this checks over, you can say, hey, if it is less than 30, if the analog read is there, and we've already mapped it in through LN, LEN is high, REN is high, and we've done all this, we've done the checks and everything, then we're going to say analog write, the RPWM, and times I. So we're going to take this pin here, so this is going to be the pin that you're going to use. So it's going to be REN or RPWM or LPWM, whatever we've written there. We can call it Dave, Steve, whatever, and it's going to be the same as that. So we can say, let's say we call this Dave, because the integer Dave is equal to pin 10, because we defined that. Then we're going to say here at the bottom, we're going to, we've mapped it there. Okay, we're analog write Dave, and then the value of I. Now we've said here that I is equal to whatever FPS is, and FPS is equal to whatever the map function of that is. And then it's going to pulse, the Arduino is going to pulse that and run it the way that we want it to. And then just to check it, we're going to say serial.println is a type of code you write and say I. So it's going to give us the value of I. And then we're going to print the value of FPS. So we're going to, what is our speed and what is our I value? Personally, now I think of it, I can actually like write this down to 100 and just map that I between 0 to 100, which will equal to similar to whatever. And then we're going to run it every 500 milliseconds. So we can actually change, I'm actually going to change this when we upload the code to show you guys how that changes things. And then we're going to run it from there. So now that this is in, it's been uploaded. If you run the code, then you go up to this little button here, which is verify, that one there. So let's go do that. Yeah, my cursor can't look at the video screen in the code. We're going to verify that. It's going to check if there's anything in the code, and then we say done compiling, and then we're going to upload that to Arduino. It's going to run a little code there, a little status bar there in the right corner, and now it's running. So now we can see here on the Arduino, it's going to be flashing that thing. And if we bring our serial read up, it's going to be a whole bunch. So we're just going to reset that. And it's going to start off there. And now what we're going to do is we're going to turn this guy here, and you'll see the value change, just like that. See, it's 13. But now look, now remember we said here that I is printed first and then FPS. But FPS is still less than 30. So it's not going to run. It's not going to put any power through, because we said that if FPS is less or equal to 30, I must be 0, which it there clearly is. So whichever code you run first is going to go through, and whichever code you write last will be the last thing to display. So we're going to move it up a bit, and we're going to look when this thing starts running up. And there he goes. There he goes. If you look here, so around about 50, I can crank it up all the way. Now listen clearly. I go, it's doing a little song there. It's going to be linked to that. So the response time is still a little bit low on this. So let's stop that motor for now. Right. It's going to be less than 30 and it switches off. So we want it to be a little bit faster. We're going to go here with the delay and we're going to change that to a 10. Right, 10 milliseconds. 10 only has 1 0, right? And we're going to verify that, right? Verify it. Check that our code is correct. Done compiling. And we're going to upload it. Uploading in the bottom corner, and we have no errors. And then we're going to look at the serial here. Now look at how quickly it's flashing now. So you can see that that's TX light is now a little bit faster. So if we run this up now, it's definitely a whole lot smoother. You can just see how quickly this responds. Now keeping in mind this is still 10 milliseconds. You can even take this down to 1 millisecond and then run the same thing. So this gives you an idea of basically like how the Arduino works. So we're going to put this in the car, and that's going to regulate the fuel pressure, and I'll show you guys, the problem of what we're having and why we're using this setup and not just connecting straight to a relay with a little flip switch and all that. Yeah, so I'm going to leave it there. Guys, thank you so much for supporting me over the years. I do hope that the future content I'll be able to provide you guys is going to be a whole lot better, and we shall see in future how this goes. This was a very long-winded explanation, a very rough explanation, and I do believe that in future I'll be able to say this a whole lot better for you. So we're going to be doing a whole lot more of this, possibly even look at like a park distance controller, maybe even like reverse cameras, heat sensors, all kinds of lovely things which you can integrate into cars, especially like with the CAN bus communications. It's going to make stuff a whole lot easier. And there's so many cool things that you can do that this really is a very nice thing to do. So we're going to be looking at stuff like with a Nano. This is the smaller version called the Nano for the TPS that I used on there. We can look at Megas. We can look at all kinds of cool things, possibly even inverters and that. But I don't want to make any promises right now. We'll see what the future holds up. And yeah, so guys, thank you so much for being part of the journey up until now. I never thought that so many people would join my channel. And yeah, obviously I'm not very good at making videos because everything's always shaking around. But we'll try, and we'll try and upgrade things and make it better for you guys. We're gonna get more content out there, a lot more free content that other people keep to themselves. So we'll see. So yeah, the future looks good for us now, guys. And yeah, really thankful that you guys have been subscribing to my channel, watching videos. It really gives me inspiration to do more things, do more advanced things that people aren't covering. Yeah, I'm just really thankful and almost at a loss of words. Like I really do appreciate it, guys. Okay, so I'm video's getting long. I'm gonna cut it off there, and I'll see you guys on the next one. Take care and drive safe.